Yes, this is Dr. Senthil Kumar, Associate Professor, Department of EEE, SNS College of Technology. This is the video lecture for the course Digital Electronics and Linear Integrated Circuits. And in the last two videos, we come across SR latch and SR flip-flop. Now we are discussing about D flip-flop. D flip-flop, D stands for data or delay. The drawback of SR flip-flop is nothing but when both S and R equal to 1. When both S and R equal to 1, the output Q and Q bar will be the same value, which as per the rules of digital electronics, the Q and Q bar should not be same. You mean if Q is 1, then Q bar should be 0. Right. How this drawback can be overcome? And see here, as per the block diagram, a SR flip-flop is shown here, whereas this drawback is overcome by connecting a NOT gate. In between S and R. I think that you may visualize that circuit. A NOT gate is connected in between S and R, such that both the S and R should not be 0, and it will not also be double 1. You mean S equal to 1 and R equal to 1 not be the same, since a NOT gate is connected. Therefore when S is 1, R definitely be 0, and when R is 1, S definitely be a 0. Therefore both the values of S and N will not be same, such that the drawback of SR flip-flop is overcome here. The drawback of SR flip-flop is overcome here by connecting a NOT gate. Whereas as per the truth table and the excitation table, it remains similar to SR latch or SR flip-flop, whereas when S equal to 0, R equal to 0, and S equal to 1 and R equal to 1 doesn't exist. See here, this is the entire circuit diagram of a D flip-flop. It consists of 4 AND gates for SR flip-flop, and another NAND gate is acted as a NOT here, is connected, and D stands for delay or data. Whereas see here, since the clock pulse is also given, when the clock is 0, as per the previous discussion, the clock is 0, it is nothing but in disabled conditions, and when clock is 1, it is an enable point, and when D is 0, for clock is 1, when D is 0, then set is 0. When D is 0, then set is 0, which means that reset is 1. We know that when reset is 1, as per SR latch, when reset is 1, the output is 0. See here, the output is 0. You mean Q. Similarly, for the next input, when D is 1, which means the set is 1, or otherwise R is 0. When set is 1, as per the RS flip-flop, when set is 1, the output is 1. See here, the Q is 1. This is the truth table, and let me discuss the excitation table or the characteristics table here. Here again, C is your clock and D is your delay or data input D. When clock is 0, then data input is nothing but don't care conditions, which is represented by the letter X. Therefore the present state, whatever may be the present state, is assumed. If it is 0, the next state is 0. If it is 1, the next state is also 1. You mean the comment is nothing but no change. Whereas when your D is 0, when clock is enabled, see the third and the fourth line. In the characteristics table. Third and the fourth line in the characteristics table, which means that D is 0. the assumed value, whatever may be the assumed value, when D is 0, reset is 1. If reset is 1 as for RS latch or RS flip flop, reset is 1, which means that the next state or the output Q n plus 1 or Qt plus 1 is 0. Similarly for D is 1, the Qn plus 1 is 1. The Qn plus 1 is 1, which means that it is set. Okay, hope you understand this D flip flop, and it is almost similar to RS flip flop, whereas the drawback of RS flip flop is overcome here with the help of D flip flop, whereas both the input of RS is not the same. And this flip flop can be utilized for counter applications and shift register applications where a delay is required. Shift the registers. Thank you for patient listening.